We're now ready for lesson 210. You can see our title there is Perpendiculars and Distance. There's really two objectives that we want to cover in this lesson. You can see them listed there. We're going to start with problems involving finding the distance between a point and a line. And then we'll move to a different type of problem where we find the distance between two parallel lines. Okay, so let's get started with our first objective, the distance between a line and another point not on the line. The way we find that, and we're going to do some examples, but I thought we would just define, maybe put a little definition to this before we get started. What we're doing here is we're finding the length of the segment that is perpendicular to the line from a particular point. Okay, so let's just take a look at our next slide. We'll do some examples. Okay, so we see here that our instruction is to find the distance from a point to a line in the coordinate plane. You don't have to graph these, but I just thought for this first example I would just go ahead and show you a picture, and that might help provide a little bit better explanation about the process that we're going to follow in coming up with the answer. So we're told that line L, which I've got pictured here in red, contains the point -5, 3 and the point 4, -6. So you can see how L has been drawn there. And we're supposed to find the distance between line L and point P. Well, going back to that definition that we just laid out on the previous slide, that's really like finding this segment that I've got in green here that would form the perpendicular, form the right angle. And so when we find that distance, then we'll know exactly, when we find the distance of that segment, we'll know the distance between point P and line L. All right, so our process is going to look like this. We first have to come up with the equation for line L. So we've had some practice with this in previous lessons. We need to find out what the slope of line L is. So remember your slope formula, y2 minus y1 over x2 minus x1. And we end up with -9 over 9. So the slope for line L is going to be -1. All right. And so now let's pick either one of these points to use in the equation. I'm just going to go with 4, -6. Really doesn't matter which one you use. So y equals mx, and now we'll solve for b. So this is going to be adding 4 to both sides, and we got our b value is -2. So the equation for line L is y equals -x minus 2. Okay, well, that's important because we have to know the equation for this line that would be perpendicular to L. All right, so that's going to be the next move, is what is the equation for this green line? You can give it a letter if you want, but we need to know what this equation would be. Well, we know the slope would be +1. Okay, and so we know that one of the points for sure on line P is the point 2, 4. So let's plug in y equals m, which would be +1 since they're perpendicular, x is 2, and then plus b. All right, and so we do the subtraction 2 from both sides, b is equal to 2. So this equation for the line perpendicular is y equals +x plus 2. Okay, so now that we know what these two equations are, we want to know what this exact point of intersection is. Now, I've pretty much already laid it out for you, but you're not going to be able to see necessarily what this is. You're not going to have to graph these. It's not always easy because sometimes this point of intersection is a fraction. So what you can do anytime you want to know what the point of intersection is of two lines, or a line in this case with the line segment, is we solve what is known as a system of two equations. And we'll get into this more heavily later on, but our two equations are the equation for L and then equation for this green segment that is perpendicular to L. And the way we solve a system, we really have choices. We can do elimination, we can do substitution. I'm just going to do the substitution method. And since y is equal to x plus 2, substitution says I can replace this y, for example, with x plus 2, and I can solve for x. So x plus 2 is equal to negative x minus 2. And then I add x to both sides, that's 2x. I subtract 2 from both sides, that's negative 4. So I got the x value of negative 2. And then I can plug negative 2 back in, for example, here, and find out that y is 0. So the point of intersection, without me seeing the graph, I know that these two are going to intersect at negative 2, 0. Okay, so now it just becomes the distance formula between that point of intersection and point P. All right. So remember the distance formula from a few lessons ago. We've had it on several tests. It's going to be the difference between the two x coordinates of these 2 points. Okay, so remember this is negative 2, 0, and P is 2, 4. So the difference between those, 2 minus negative 2, quantity squared. And then the difference between the y's, that would be 4 minus 0, quantity squared. And let me go ahead and put another parenthesis there. So this is going to be 4 squared, which is 16. And this is also going to be 4 squared. So the way I want you to do your answers, just so we can practice simplifying radicals, is I want you to do 2 things. I want you to go ahead and simplify the radical, simplified radical form. So the square root of 32 would be 4 times the square root of 2. And then once you've got the simplified radical, I want you to go to your calculator and give me the decimal form of that. So just 4 times the square root of 2 and your calculator. And we'll just do these to the hundredths. So in hundredths, that would be 5.66, and then we'll just say units. We don't know what they are exactly, but we'll just say that it's 5.66 units from point P to line L. Okay, so that's going to be the process. We'll do a couple more examples of these. Find the equation for the given line. Find the equation for the line that's perpendicular to that. Find out where the point of intersection is of those 2 lines, and that point of intersection and the distance between your given point, the distance between those 2 points will be your answer. All right, here's another example. And again, you don't have to graph these. I just wanted to do that first one just so you could have an idea. So let's find out first of all what the equation for line L would be. So we do the slope formula. 4 minus 2 is 2. That's the difference between the y's. And then 5 minus 1 is 4. We reduce, and we get a slope of 1/2. And now let's pick one of these points to use to come up with the equation. I'll just go with this one. Y equals mx, and we'll solve for b. And we're going to be subtracting 1/2 from both sides, so you can think of this as 4/2 minus 1/2. So b is 3/2. And so our equation for line L is going to be y equals 1/2 x plus 3/2. Okay, and now in the next step we're going to do is find out what the equation for the segment that is perpendicular to this would be. All right, so we know the slope has to be -2, and we also know that that segment contains the point 17. All right, so let's plug in y equals mx, and we'll solve for b. So we add 2 to both sides. We got b is 9. So the equation for the segment that would be perpendicular to L would be y equals -2x plus 9. Okay, so we got our two equations, and now we're going to put these together as a system and solve. When we solve a system, we're basically saying where these two would intersect. All right, and so again, I think substitution makes sense. I'm just going to let -2x plus 9 replace y, and we'll find out what x is. So here is substitution. -2x plus 9 equals 1/2 x plus 3/2. All right, and you can think of -2 as -4/2. We're going to add 4/2 to both sides. That would make 5/2 x. And then I'm going to subtract 3/2. So if you want to think of 9, I like for you to work with fractions instead of just defaulting to your calculator and changing the decimal. So if you change 9, that would be 18/2. All right, and we'll be subtracting 3/2, so that's 15/2. All right, and then to solve for x, we'll multiply by 2/5 on both sides. And these 2's would cancel. 15 divided by 5 is 3. So we got our x value of 3. And then to find out, well, that's the x-coordinate of where these would intersect. What's the y? Well, we can come up here and replace x with 3. -6 plus 9 is also 3. So 3, 3 is where they intersect. And now it's just a matter of finding the distance between these 2 points. The point 17, which is P, and that point of intersection, and that will get us our answer. So here we are back to the distance formula. The difference between the x's, 3 minus 1 squared, plus 3 minus 7 squared. 3 minus 1 is 2, and that's 4, 2 squared. And this is -4 squared, which is 16. So we get the square root of 20. So again, let's practice simplifying radicals. That would be 2 times the square root of 5 in simplified radical form. And then you can go ahead from there and give me the decimal form in your calculator. That would be 4.47 units. Okay, so it's really a two-part answer: simplified radical and then rounded decimal to the nearest hundredth. Okay, got one more of those. So here we are again. We need to find out what the equation for line S is. So we got to find the slope, 5 minus 0 over -5 minus 0. So the slope of line S is -1. We already know that the y-intercept for line S is 0, so we don't really have to solve for that. So b is 0, slope is -1. So the equation for line S is going to be y equals -1x plus 0, which means just -x. All right, so that's the equation for S. Now let's find the equation for the segment that would be perpendicular to that. So that would have a slope of +1, and it passes through 1, 5. So y equals mx, solve for b. 1 would be subtracted from both sides, so b is 4. So the equation for the segment that's perpendicular to S would be y equals x plus 4. Now we set these equal to each other so we can find out what that point of intersection is. So again, this is an application of substitution and solving a system of two linear equations. So I'm just going to let this y replace this y. So x plus 4 is equal to -x. If I subtract x from both sides, I get 4 is equal to negative 2x, and then I divide by negative 2, and I got x is negative 2. And then that's the x-coordinate of that point of intersection. And then if I replace x here with negative 2, I get the y-coordinate. And now I'm looking for the distance once again between these 2 points. So back to the distance formula. The difference between the x's, quantity squared, added to the difference between the y's, quantity squared. So that's going to be negative 3 squared, which is 9. Negative 3 squared again, also 9. That's the square root of 18. Show me what that is in simplified radical form. So that would be 3 times the square root of 2. And then you can show me the rounded decimal form, which would be 4.24 units. All right. And there's our 3 examples for that first objective involved in this lesson. All right, now let's move on to some examples of the other type of problem you're going to be doing in this lesson, and that is finding the distance between 2 parallel lines. And so again, for this first example, we'll look at a picture. You don't have to graph any of these. So let's go ahead and define really what we're doing here. Kind of similar to what we did before, but a little different. When we find the distance between parallel lines, it's the distance between, it is the perpendicular distance. So we're doing a lot of work with perpendicular lines, the perpendicular distance between one of the lines and any point on the other line. All right, and so what we're given here is the equations for line L and M. I went ahead and just showed you in picture graph form what we're doing. And again, graphing is not required. So what we want to do first is find out what the equation for a line that would be perpendicular to L and M would be. Okay, so obviously both of these have a slope of 2. So for a line perpendicular to them, we would use a slope of negative 1/2. Okay, so we're trying to write an equation for a line that would be perpendicular to both of these. And then when we find out what that equation is, then we're going to try to find the length of that actual segment that connects these two. All right, so to use, I can use either one of these y-intercepts, okay, because what we're actually doing is we're saying that this perpendicular segment would, for example, go through 0, 1 of L, and then it's going to come over here and hit M someplace. Well, we don't really know where that is, but we can figure it out. So let's just say that we're going to use the y-intercept of L, which means B is going to be positive 1. So that makes it easy to find the equation for the line that's perpendicular. That's y equals negative 1/2 x plus 1. All right. And so now what I'm going to do is I'm going to find out where that actual point of intersection is. All right. So if I did just pull up my line draw here. So we're saying that we've got this segment that goes through 0, 1, and I'm just going to make a segment. I don't know if that's exactly perpendicular or not, but what I'm interested in is where this point of intersection is. Where does that green segment hit M? Well, to know that, I take the equation for the green segment, and then I take the equation for M. Notice these are in order, so this is M. And I solve this. This is a system of 2 linear equations again, so I'm going to use substitution, and I'm going to find out what that point of intersection is. So M is 2x minus 3. I just let that replace the y. And now I'm going to solve for x, so I can find out where that intersection point is. And if I know what that intersection point is, then I can find out that distance pretty easily. Okay, so I'm going to add 1/2 x. So again, this is 4/2 plus 1/2, that's 5/2 x. And then I'll just go ahead and add 3 to both sides, so that's 4. All right, and then I'm going to multiply by 2/5 on both sides. And when I do that, I get 8/5. So x is 8/5. And now to solve for y, I can go up here in this equation that is already solved for y, and I can replace x with 8/5. So y is going to be negative 1/2 times 8/5 plus 1. And that is negative 8/10, which reduces to negative 4/5. So negative 4/5 plus 5/5 is positive 1/5. All right, so now I know exactly where that point of intersection is. It's the point 8/5, 1/5. All right, so now let's find out what the distance between L, which that point is 0, 1, and this point on M, which we've identified as 8/5, 1/5. So we're back to the distance formula. And so the difference between the x's, okay, so we have 8/5 minus 0, which is 8/5 squared. And then 1/5 minus 5/5 would be negative 4/5 squared. And I'm going to get kind of crowded down here. So if we go ahead and square this, that's going to be 64/25. And that's going to be 16/25. Maybe I'll move up here. So 80/25. And again, this is good practice on simplifying radicals. So the denominator just becomes 5. Remember, the square root of a fraction is like the fraction of the square roots. So the square root of 25 would become the denominator, and then the simplified form of the square root of 80, remember we can use the square root of 16 times the square root of 5 to represent the square root of 80. So that's 4 times the square root of 5. So that would be the simplified radical form answer. And then go into your calculator. That would be 1.8. I didn't write down the hundredths, but be 1.8 units. Let me just see if I can get that for you real quick. 4 times the square root of 5. And divided by 5. It's actually 1.79. So let me change that, 1.79. We'll just round all of these to the hundredths. All right, so that's the idea behind what we're going to be doing on these others. If you have to graph these to help you, that's perfectly all right. It's just not required. All right, so let's find out first of all, what is the equation for the line, the segment that would be perpendicular to these? So that would be y equals positive 1/3 x, and we'll just, it doesn't really matter which one of these you use as your y-intercept. Let's just say we want to do plus 6. So that's the equation for the line that's perpendicular to R and S. All right, and now we're going to find out what is the point of intersection then. Since I chose this, I want to know the point of intersection between these two. Okay, so let's set those up as a system. 1/3 x plus 6 is equal to negative 3x minus 5. So again, this would be negative 9/3 that I will be adding to both sides. I'll be adding 9/3. This is negative 9/3. I'm going to add 9/3 to both sides. So that's 10/3 x. And then I'm going to subtract 6 from both sides. That's negative 11. multiply by 3/10 on both sides. And I got my x value is negative 33/10. And then to find out what the y coordinate of that intersection point, I just plug negative 33/10 in here. So let's see what that is. Y is equal to 1/3 times negative 33/10 plus 6. So that's negative 33/30, which we can reduce that down to make this a little bit easier. That's negative 11/10. And then this is going to be 60/10. And so the y value is going to be 49/10. So the point of intersection for this segment that intersects, makes a perpendicular point of intersection between these two parallel lines, is negative 33/10, 49/10. All right. And now we want to find out what the distance is between this point and this other point, 0, 6. Okay, so let's find out what that. We already found where these two are going to intersect. And now we want to find the distance between that point of intersection and the other line. All right, so the distance formula, remember that's the point 0, 6. So the difference between the x's would be just negative 33/10 squared, so minus 0 squared. And then 49/10 minus 60/10 would be negative 11/10 squared. And this gets kind of big, but this is 1,089 over 100. This is 121 over 100. You put those together, and that's 1210 over 100 square root. So show me the simplified radical. It's the same thing as this, just as a reminder. So the square root of 1210, 1,210, you can think of the square root of 121 times the square root of 10, and that's going to be over 10. So the square root of 121 is 11 times the square root of 10 over 10. So that would be the simplified radical form. And then the decimal form is 3.48 units. So there's your two answers, really, simplified radical and decimal. And we got one more problem, so let's see what we can do with this. Let's find out what the line, the segment that is perpendicular to these two would be. So the slope, remember this is standard form, but we can get the slope. The slope of this line would be negative 1/3. So the slope that I'm going to use for the line perpendicular to it would be positive 3. If you want to know a y-intercept when you're looking at standard form, just put 0 in for x and solve for y. So if we let x become 0, basically makes the x disappear. And we just solve this equation 3y equals 6, we get y equals 2. So that's the y-intercept. So the equation for the perpendicular segment would be y equals 3x plus 2. All right, and so now let's set these two equal to each other. Since we use this for our y-intercept, we're going to see where these two intersect. Okay, this segment, we know these two are going to intersect at 6, but where do these two intersect? So let's set these equal to each other. And if you want, this is substitution as well. This one's solved for y, so we can just come over here if you want to leave it in standard form, and you can just replace the y with this. So x plus 3 times 3x plus 2 is equal to negative 14. And the distributive property, 10x is equal to negative 20, so x is negative 2. And so now to get the y-coordinate of that intersection point, we can go up here and let x be negative 2. That's negative 6 plus 2, and that's negative 4. All right. And so now we want to know the distance between this point and 0, 6, which is the y-intercept of that other equation, that line. All right, so think 0, 6, negative 2, negative 4, so the distance, the difference between the x's and the difference between the y's. Realized I made a big error. I'm thinking that was in slope-intercept form, and it's not. That's not the y-intercept. Sorry about that. We should be using a y-intercept of 2. We talked about that earlier. Sorry, forgot we were in standard form, so I need to change that. Doesn't change the x's, but the difference between the y's will be 2 minus negative 4. Quantity squared. All right, so this is going to be 2 squared, which is 4, 6 squared, which is 36. It's a square root of 40. In simplified radical form, that would be 2 times the square root of 10. And then in decimal form, rounded, that would be 6.32 units. All right, those are my examples for this assignment. I hope that helps with the 2 objectives that we wanted to cover and prepare you for the assignment that will be due the next time. If you have any questions, feel free to reach out to me, and I will see you next time.